All right, so just quickly go ahead and go to code.quarkus.io. So this platform will give you something like a Spring initializer if you are familiar with Spring Boot. So what this does is it automatically generates the projects for you and automatically adds the dependencies that you want to use. So in this tutorial, we're simply going to create a simple REST API using Quarkus. So in this case, we are not going to use Java. I'm simply going to use Kotlin. I'd like to take a different approach this time. So instead of using Java, I'm going to use Kotlin. So Kotlin, one of the advantages of Kotlin is it allows you to write less number of lines of code. So if you're familiar with Java, with Kotlin, it's easily translated like that. So it will be easier for one to actually read Kotlin code if you're familiar with Java. So in this specific tutorial, we're simply going to use Kotlin because it's faster in terms of development time, because we'll be writing less number of code. So just like the what you do if you're familiar with Spring, let's quickly go ahead and initialize our values here. So for the group, I'm going to simply put the name of the channel. So I'm going to use com.stackdev. Then for the name of the project, I'm simply going to call it Quarkus REST API. Then this time I'm not going to use Maven, I'm going to use Gradle with Kotlin, and version I will leave it like that. This I will leave it like that. So for the dependencies that we need to use, first of all we need to use Quarkus Kotlin so that it will be able to pick the best language that we're going to use. So in this case, like I mentioned, we're going to use Kotlin. So just quickly go and tick this, and then it will add it to the dependency. So now you can see we have one dependency that we have added, which is Kotlin. So the next dependency that I want to add, since we're going to create a RESTful API, I'm going to use something called Quarkus REST, right? So I'm simply going to say REST, right? So in this case, Quarkus has it now, like I mentioned before, Quarkus it's mainly it was developed with reactive in mind, right? So in this case, we're not going to use the Quarkus reactive for now. So for now, we are simply going to use the REST Easy Classic, right? So that's the one that I'm going to pick. Then for the reactive one, I think we'll do tutorials on that. So right now we just want to start from the basics. So I'm going to use the REST Easy Classic. Then for us to be able to serialize our DTO and etc., for serialization, we're going to use Quarkus REST Easy JSON, right? So in this case, we're going to use JSON. So Quarkus, for its RESTful endpoints API, it performs it by using the JAX-RX. So that's the one that we are simply going to use in this tutorial. So for serialization, I'm simply going to use REST Easy JSON. So just quickly go ahead and check that. So now we have 3 dependencies. Then the third dependency that I might need to add is I want to, for our ORM, I'm simply going to use Hibernate with Panache. So I'm simply going to say Panache, right? So that will be able to automatically create our classes to our database and etc. So in this case, I'm going to use Hibernate ORM REST with Panache. So I'm simply going to add this, right? So this is for our ORM. Right, then for our database connector, we are going to use Postgres. So I'm going to say Postgres driver. Then what else? I think for the most part that's it. Maybe for us to be able to view our API, I'm going to use maybe the OpenRail Open API, right? So now that you have these 6 dependencies installed, just quickly go ahead and click Generate Application, and then you download the zip. All right, so once you have initialized your project, you should have something similar to this, right? So what you see in this project is just like a normal Java project, right? So we have the main. So in this case, since this is Quarkus, it also comes with some tests for native testing, right? Because remember, Quarkus was built mainly in mind with native testing. So it also have the normal tests for testing your resources, right? So these ones we are not going to do much in them. We'll do a separate video for unit testing in Quarkus. So once you open the main folder, so let me just close these ones. Once you open your main folder, it has 3 folders, right? There's a Docker folder, the Kotlin, and the resources, right? So inside the Docker folder, this is the build of Quarkus, right? It also comes with the Docker files for all your different mods, right? So it has a Docker file for the normal JVM mod, right? So the normal JVM mod, like the one that we are replacing, the one that is not container friendly, this is the normal JVM Docker image, right? So that's the build of Quarkus, right? So this is the normal JVM. Then it also has a Docker file for the JVM jar legacy, right? So this is also run on top of an OpenJDK, the normal Java virtual machine. So it also has a Docker file for that. So I don't need to worry about creating Docker files to bundle or package your application. Quarkus comes with that, right? Then it also have a Docker file for the native image build, right? So for this one, this is a no JVM mod, which means this one will be using GraalVM to actually bundle your application to run natively on Graal, right? So for native build, which is why we're here today with Quarkus, this is the Docker file that you need to use to build your native images, right? So as you can see from this one, it's importing from the Radiat registry, image registry, right? So this one will be running with Graal virtual machine. Then it also has a Docker file called micro. So this one will be a Docker file for the micro, which is even better than the native one. But for the most part, they both run on the GraalVM and they also achieve the same thing. So this is a more optimized one than this one. But for the most part, you can either use any one of them. So this is the Docker. So we'll demonstrate how to run the Docker or to package your application maybe towards the end of the video. So once you open your Kotlin main folder, you actually see that it comes by default with a single REST endpoint. So in this case, since we're using REST easy, so which means our application for the most part it will be blocking, right? So remember, there is also Quarkus REST easy that is reactive for non-blocking APIs. So this one will be, so for this tutorial, we just demonstrate with the classic one, which is the blocking REST easy API. Then we'll do a separate video for looking at reactive APIs in Quarkus, which is the reactive REST easy. So in this one for the most part, it will be blocking, right? So once we have that set up, right? So we also has, Quarkus also has this README application, this README file, right? So this README shows you how to actually go ahead and run your application. So like for example, it shows you how to run your application in development mode. Just simply need to run Quarkus Gradle glue Quarkus dev, right? So if I run that command, you should be able to to start up my application in development mode. Then also Quarkus has something called, in development mode, it also has something called Quarkus dev UI, right? Which is pretty cool. I'll show you shortly. So this one also has, it also shows you how to package your application, right? So if you want to package your application, just like what you do with any normal Java application, you build your application. Then once you build the application, then you build the jar, and then you will be able to run the jar, right? So this is how you run it in the normal JVM mode, right? Then for running it as a native executable, you build your application with the packaging type of native here, right? Then once you build it, right, you then, it is sort of like a create a Docker image in your local whatever you're building this from. Then you'll be able to run sort of like to spin up your container from that Docker native executable, right? But if you have GraalVM installed in your machine, you can quickly go ahead and run this command if you have Graal virtual machine installed. So in this case, I think I'm using the normal JVM, right? So I'll have to run this on a Docker, and then I'll spin up the container from the native executable. But if you have GraalVM installed, you can simply go ahead and do this, and then you run the native executable image. I think we'll demonstrate that, right? So this is the README. So if you open the dev UI, the console that comes with Quarkus. So if I copy this link, and then we simply go ahead and go to our browser. So if you go to our browser and we open a new tab, right? So in this case, I just want to show you the dev console, right? So the dev console is it's pretty cool, right? So Quarkus, one of the advantage of Quarkus as well during development, why they call it a developer joy, is because when you are developing your application, Quarkus by default, it also comes with hot reload, right? So which means if you make changes, the application automatically reloads, right? So for example, in this dev console, what you can see the ORM. In this case, we're using Panache for Hibernate, right? ORM. Then for our UI, for our Open API, in this case, it also comes with this Open API, which also has the Swagger UI console. So if I open the Swagger UI, in this case, we simply have one resource, right? So if I simply say try it out and then I run this, right, it also returns hello from Rest Easy, right? So let me simply go ahead and show you the hot reload that comes with Quarkus, right? So if I simply jump back to my Spring application, and then let's say I make a change in my default resource, so I can say hello Rest Easy. Let's say I say from StackDev, right? If I save this, right, so Quarkus automatically reloads this, right? So which means if I am to go back to the browser, right, if I go back to the browser and I go back to my Open API and then I rerun this endpoint, right, I say execute, right, it will have the new change, hello Rest Easy from StackDev. So what this means is, with this hot reload that Quarkus comes with, you don't have to sort of like manually restart your application. As you develop, it will be reactive as well as you develop in terms of hot reload, right? So this is the dev console. So the dev console is also here on a browser, which is pretty cool, to be honest, right? So this is where you can see your things, different things and resources on your application. All right, so for the most part, I think that's it in terms of the Quarkus dev UI and also the resources, the pretty cool things that it has. So right now, let's now quickly jump into the coding, where we simply want to create a user registration form, registration API, where we can actually go ahead and register our clients in our API. So stay tuned. All right, so once you get back to your code, just quickly go ahead to your dependency file. So one change that I made here is on the Panache ORM that we had imported. So we had in my case, I imported the Kotlin one. So this one will bring you issues. So just make sure that you import the correct one without the Kotlin, right? Because this one, it has some dependencies, some methods that it doesn't have. So for example, like find by optional, right? So you just need to make sure that you import the correct one. Then also another change that I did, since we're using the Rest Easy that is blocking, just make sure that you comment the one that is reactive, because if you try to run it with these two dependencies, it will clash, right? So once you get that out of the way, when you restart your application, I think you should be able to good to go. So the first thing that I need to do here is, since I'm creating a Restful API, I'm simply going to package my applications into different packages, right? Just like what we do with our normal Java tutorials. So in this case, I'm going to create a package called models. So inside this model, I'm going to create a Kotlin class, right? An entity class called client details, right? So this is going to be my model, and it's going to be called client details, right? So inside this class, I'm going to annotate it with @entity, right? So since we're using Kotlin, right, the main advantage of Kotlin is, like what I mentioned earlier, it allows you to write less code, right? So which means in this case, for your entity, you don't need to put your accessor methods, just like what you do with normal Java classes, right? So this one is going to be actually a data class, an entity data class, right? And since I'm not going to put constructors and non-default constructors and accessor methods like the getters and setters, in Kotlin we just create it as an object, right? So when I put my fields, so for example, let's say I want to put a primary key, and generated value, right? So in this case, I'm going to have an ID, right, which is going to be a primary key, and it's going to be a long. I'm going to, let's say, initialize it, let's say to 0, right, for example, right? So for all your attributes for your table or for your entity, right, you need to put it in an object like this with Kotlin, so that you won't have to actually go ahead and put accessor methods, non-default, default constructors, and etc. Right? So here I'm simply initializing I'm creating my attributes for my table, right? So I have name, surname, it's going to be a string. I'm going to initialize it to now. Then we have, let's say, age. So age is going to be, let's say, an integer, right? So age is going to be an integer. Then I'm going to have maybe an email. It's going to be a string again. So I'm going to initialize it to now, right? It can be now. So I'm going to have, let's say, basic salary, right? So this is going to be a double, right? And it's also nullable, right? So once you have done this in Kotlin, right, this is the beauty, right? So for the most part, you're done with your data class, right? So which means you don't need to put your getter, your setter. If you do this in Kotlin, by default, you have access to the data, to your setter, to access modifiers, right? Because remember, Kotlin runs on top of Java. So once it compiles, it then compiles this class into normal Java classes, right? So once you are done with your model, the next thing that I might need to create is to be able to write my database queries and etc. I'm simply going to create a separate package called repository, right? So just quickly go ahead and create a package called repository, right? So I'm going to call it repositories. So inside this repositories package, right, this is where I'm going to create my repository interface class, right? So since you're using Quarkus, so also with Quarkus, right, you can, if you don't want to create a separate repository class, you can always actually go ahead and extend the ORM from your entity class here, right? But if you do this, what you would have, you have access to the normal, you have access to the normal methods that comes with your entity, right? So the normal ones like the delete, the find by ID, the normal methods, find all. So the normal ORM operations list that we have, these are the ones that we have access to. But if you want to create your own custom methods in terms of accessing your database queries, you might as well need to create a separate class for that, or you might need to put some logic here. So for the most part, I like to keep my entities clean, so I'm not going to extend it here. I'm simply going to create a separate class inside a separate package called repositories. So inside this repositories, I'm going to create a class called client details repository, right? And it's going to be an interface, right? So inside this interface, this is where I'm simply going to extend my Panache ORM, right? Just like what you do in normal Spring application. So the first thing that you need to do for your class to be able to be recognized by other packages and classes, you need to sort of like scope it, right? So you need to put it application scoped, because if you don't scope it, when you try to access or try to inject this class in a different class, it won't be recognized. So you need to scope it like this, so that Kotlin, when it runs, Quarkus will be able to recognize these classes, right? So what you need to do, just like what we normally do in other, for example, Spring project, you need to extend your ORM. So in this case, I'm going to extend my Panache repository. So remember, in Spring, you extend your JPA repository, then you pass your class and your primary key. So in this case, you simply pass your entity, right? So you are extending the Panache repository so that you'll be able to access the methods that allows us to write queries to our database, right? So in this case, I'm simply going to extend the model or the entity that we created, right? Like so. So once you've done this, you're actually for the most part done. So this is similar to Spring. So if you know Spring, it will be easier for you to translate. right? So once you have extended your repository like this, so let's say you want to have, you know, like maybe other query methods that are not inside this Panache repository base, right? So if you have methods, for example, let's say find by name and etc., these ones won't be here, right? Or you want to run your custom queries, right? You can always do it here. So let me simply go ahead and create a function called find by name, right? And this one is going to be an optional, right? So it means it can also be null. So here I'm simply going to pass the name, right? And it's going to return a client, right? It's going to return a client object, right? So since this is an optional, I now need to write my query. So this is how you do it in Quarkus. So for the most part, you need to pass your query parameter, and then you pass your value, right? So the query that we're simply writing here, we're simply writing a query called select all from select all from client details when name is equals to this value that would have passed here, and then you simply return the first object of that specific query, right? So this returns the client details. So this is how you do your custom this is how you actually do your custom queries, right, inside the repository. So once you have done this, the next thing that we probably need to do, we now need to create our service, right? So our service is going to be between the controller, which is the normal API that interacts with the client, and then the database relationship. So we're going to simply create a package called service, right? So inside our service, this is where we're going to implement our business logic. So in this case, I'm going to simply create a Kotlin class called client. So client details service, right? So inside this client details, so I've misspelled it. So let me simply create rename the class. So it's client. Okay, client details service, like so, right? So again, the first thing that you need to do, you need to annotate your class with application scoped, so that it will be able to be recognized, right? So here we simply put application scoped, right? Once you put your application scoped, the next thing that you need to do, since we are simply going to write some transactional queries to our database, I'm simply going to, for example, serving data to our database, I'm simply going to annotate our service with a transactional, right? So for us to be able to implement our business logic, the first thing that we need to do, we need to be able to inject our repository that we created, right? So to inject classes in Quarkus, you simply add the annotation at inject, right? Then you bring in your repository. So in this case, it's going to be a let-int variable called client repository. So dev client repository, right, like so. So this is how you inject your repository inside your class, right? So you simply annotate it with at inject, like so. So this is how we do our automatic dependency injection in Quarkus, right? So since this is going to be a CRUD API, so let's implement our business logic, right? So for serving our client, I'm simply going to create a function called fun. Then I'm going to say serve client, right? So for serving our client, so this one is simply going to take a client details object from a model. So this is client, I don't know why I'm messing up with the spelling, client details from our model, right? And once we have done that, this simply returns, this will simply sort of like save our client, right? So to save our client, we're simply going to say, so this is going to be a function, right? So this is going to say, we'll simply call our repository, right, from Panache. Then we simply go ahead and say save. So there's no save here, so I think there is persist, right? So you say persist, then you persist your object. So this is how you create the client details object, right, in your data, in your table, right? So that's all, right? So let's now do a find all, right? So for find all, I'm simply going to say for find all, I want to return a list of client details, right? So if I want to return a list of client details, I'm simply going to say return client repository dot, I think it has find all. Do you have find all? So since we are taking a list, we could use, I think there's list all here, right? Because we simply want to return a list. We simply want to return a list of users, right, of client details. So we can simply do this, right? So that's it, right? So the next method that I need to do, let's say I want to say find by ID, right? So find by ID. So for find by ID, we're simply going to pass our primary key. So remember, we defined it as a long. Then this class, in terms of the return type, is going to return a client object. So it's going to be a client details object. So we want it to be an optional. So we put a question mark. So which means this can also be an optional, which means that we can also return now, right? So in terms of our return, we simply want to return client repository then dot find by ID. So in this case, we simply want to say this can be an optional, so that we'll be able to do or else, and now we implement our optional, right? So or else this can return a now, right? So what this means is if we say find by ID in our business class, then if we don't find the client, we simply return an optional, or simply return an optional which allows us to return a now if the client is not found. So this is how we do it. So remember, we had created our own. So for the most part, these methods that we've used, these are the default methods that comes with our ORM, right? So let's say you want to run your custom query. So let's say you say find by name. So remember, we had created the find by name. So in this case, it takes a name, right, which is a string, right? And then this one, it returns a client details, right? So it returns a client details like so. So this one, we want it to be an optional again. So for example, if we don't find the client, we want it to be able to return an optional. So remember, we had created a method called find by name optional. So we simply pass the name that we have here, right? So this is how we do your find by name. Then the next, so for our CRUD, the next one maybe will be delete client, right? So let's say we want to say delete client. So again, we delete by the ID, right? So once we delete by the ID, the query that we simply want to run, client repository dot delete by ID, we simply pass the ID. So this will delete our client. So we are done. So the last one, maybe we can write maybe the update client, right? So for the update client, we want to be able to pass our client details. So our client details object, right? So once we pass our client details object, what you simply want to do is we simply want to delete, right? We simply want to update, right? So the way we're going to update, we're simply going to call our repository actually. So we simply say client repository then dot update, that comes with our Hibernate ORM. Then for our query, we're simply going to say what we want to update. We simply want to say if the name is provided, right, we simply want to pass the client details that would have come from our client. So it's going to be a name, right? Then we simply update that one, right, like so, right? So what this means is we're simply saying, so for our query, so if we have a different name here, it will update the name object, right? So we simply want to do this for the rest of the objects in our class. So we have so in this case we had name, the other one was surname, right? So we simply update with the surname. The other one I think was age, so simply update the age. Then we have email, right? Then we simply update the email, and I think we also had, was it basic salary, I think. Then we simply update the basic salary. So we simply want, so this is our query, right? This is our query that we're passing. So we simply want to update these details. Then to finish our query, so we're simply sort of like outer table, update table, this table, set values to this where ID is equals to, since we had passed our ID here, this is where we need to implement it. So where ID is equals to client details dot ID. So since we are passing the client object, we then extract the ID from the client detail. So in terms of implementing our CRUD, our create, read, update, and delete methods in our API, in our service in this case, I think for the most part we are done, right? So the last thing that we probably need to do is now to create our controller, right, or our resource, right? So in this case we had this default resource. So this one I'm simply going to keep it there, but I'm going to create a separate package called controller, right? Controllers. So you can call it resources or controllers, depending on how you want to call it. So in this case I'm simply going to call it a controller package. Then I'm going to create a Kotlin class called client details controller. So again, this is a resource class. Okay, so let me not call it controller, so I'll simply call it client details resource, right? Just the naming actually. So in Kotlin, in Quarkus they call it resources, but in other languages, for example frameworks like Spring, they call it controllers, right? So in this controller, so remember, for our controller method, in this case we are going to use the JXRX API client that comes with Kotlin. So in this case, just like what you normally do, for example in Spring, you simply need to annotate your path. So for example, this is a controller, so for this we'll simply need to put our base path here. So in this case, since we're using the JAX REST layer, REST service, right? So we'll simply say, so for our path, we're simply going to annotate, for our base path, I'm simply going to call it /API. So which means everything that is, all the endpoints that we're going to create in this resource, so in this controller, they're going to hit the /API base endpoint, right? So since we have created a separate class as a service to be able to implement our business logic, we need to again inject it here, right? So the way you inject is like what we did when we inject our repository in our service. So we simply do the same thing. We say @inject, then we define our variable. So in this case, it's going to be called client details service, like so. So once we have injected our service, we now want to create our endpoints, right? So for the first endpoint, I'm simply going to call it, it's a function. Then I'm simply going to call it find all, right? So to find all clients, this one is going to return a response, right? An API response. Then inside the API response, I'm simply going to say return response.ok, right? And then I will simply call my service, then find all. So what this does is it actually returns a list of users, and then I'll build the return here. I'll simply say .build, right? So for our endpoint, right, so we need to be able to tell Kotlin what this type of endpoint is, right? So for the most part, this endpoint is going to be a get request, right? And then the specific path, in as much as it is going to be called /API, so it's going to be called /API/all in this case. So I'm simply going to say /all like this. Then I'm simply going to tell Kotlin that this is going to produce a media type of application.json, right? So this is going to produce an application .json response, right? So this is how we create our endpoint, right? So first of all, we annotate it with the type of request that we want to make. So in this case, it will be a get request, and then we put the path, then we put whatever you want to produce. So in this case, it's going to produce an application.json, then we return our response. So in this case, our response was, we're using the response that comes with the JAX RX. So in this case, we're simply going to say response.ok, which is going to be 200. Then we simply pass our we call our service, which returns a list of client, and then we build that. So it will then sort of like automatically serialize it to a list of objects, right? In this case, since we're using JSON, right? So it automatically does that for you. So we are done for the most part with our find all, right? Then the next endpoint that I need to create is the find by ID, right? So I'll simply say find by ID, like so. So what this endpoint does is I'm simply going to make it take a path parameter, right? So I'm going to put a path parameter, right? And then the value of that path is going to be ID in this case. And I'm simply going to declare my ID as a long, right? And then again, it's going to return a response, right? Like so. So what this endpoint, let's simply go ahead and annotate our endpoint. So in this case, it's going to be a get, right? It's going to be a get request. And then for our path, right? So for our path, we're simply going to put the path parameter that we specified. So in this case, we're going to make the user put an ID here, right? And since this one we want it to produce again a JSON, an application.json response, right? So the first thing that you probably need to do when you want to find by ID is to get the client, right? So we're simply going to use the client service, right? Then dot find, I think we had find by ID, then we simply pass this ID, right? So remember, this was an optional, so we can actually always do something like if client is not equal to now, right? So if client is not equal to now, we simply want to return the client. So we simply want to say response.status 200, then we return the client, and we build it like so, right? Okay, like so. Otherwise, we simply want to return a response that says if the client does not exist, then we simply want to pass the status, because since the OK for the most part it returns the status 200. In this case, we want to sort of like manually pass the status that we want to tell our user. So in this case, we're simply going to import the status from the REST EasyJS RX, and then we import not found, and then we build it, right? So what this does is, if it doesn't get this client, if it doesn't exist, you simply return a message to say client does not exist, and then it will give them a 401, right, which is status not found, like so, which is client which is not found, the status, right? So for the most part, we are done with the find by ID, right? So the next endpoint that you need to create, it's almost similar to this one. It's also a get request, but in this case, this is find by name, right? So remember, we had a name. So again, in my path parameter, I'm simply going to pass name, right? So in this case, it's going to be name, and the data type of the name is going to be a string. So this is no longer find by ID, this is find by name, right? So again, it takes the name. So remember, we had in our service, we had created another optional again called find by name, right? So again, we return the response if the client doesn't exist, right? So I think we are done with our get requests. So now let's see how we do a post request, right? So to create a post endpoint, again, we need to create a function called, let's say, save client, right? So remember, our save client, it was taking the client object, right? so as our DTO, and again it's going to return a response, right? So for this one, in terms of the request type, so it's going to be a post request. So from our specification, our REST specification, the JAX-RIX, it also has a post, right? A post method. So in terms of the path, you simply put our path, right? And you say, let's say create, right? And then for this one, we simply want to tell our Kotlin or our REST endpoint that for this one, we are going to expect our client to pass the media type, a JSON object, right? So we use the annotation code consumes, right? So this endpoint, it consumes a media type of application.json, and then it produces an application.json, right? So what this means is we are strictly explicitly specifying that this specific endpoint, we're expecting it to consume a JSON object, right? Which means if the client tries to pass let's say a media file, we're supposed to receive an error, right? So we won't accept it, right? So for creating our client, again, we simply use our service, so .save client, then we pass our object. Then once we create our client, then we simply say we'll return the object that the client would have passed, and then with the status created. So in this case, I'm simply going to say response.status.created. So it's going to return a true or 1, which is the status for created, right? So this is how you do a post request, right? So remember, for the most part, if you're familiar with, so for example, with frameworks like Spring Boot, right? So Spring, it uses the Spring REST as its REST layer. It uses the Spring REST API, which means it has its own specification, right? But with JAX-RIX, right? So for example, it has implementations like REST Easy, which is the one that we use here, right? So for the most part, you see that the pattern is almost similar, right? So if you're familiar with Spring, it's actually easier for you to be able to read code in Quarkus as well, right? So for the most part, I think we are done with our create. Then the last one, maybe let's just quickly go and create the update client, right? So we had update, right? So update client. So again, this takes the client details as the DTO, and we simply want to return a REST response, right? So for this one, again, our RESTs, our JAX-RIX REST Easy has a put method, right? So for update, we're going to use put, and then for the most part, it's going to consume the RESTs, the application.json, and it's going to consume produce the application.json as well. Then for my endpoint, I'm simply going to call it update. Then what we want to update, we want to update our client, right? So to update our client, the first thing that we probably need to do is we can simply go ahead and say client, we can call our client details service, then maybe we can call our update method. So our update client, it took the client endpoint, right? And if okay, so if so the many options of doing this, this probably might not be the right one, so let's quickly go ahead and create the updated client. So we're going to say the updated client. You can say client detail service dot find by ID. So remember, when we created our update endpoint, we were, so let's use find by name, right? Because the ID sometimes we might not know it. So we're going to say client dot name, right? So this one not nullable. Then we say if the updated client, since it returns an optional, is not equal to now, right? We simply want to return that client, right? So response dot okay. So we simply want to return the updated client. So in this case, the updated client, then we build it, right? Otherwise, we simply want to tell our user that the client maybe did not update successfully, like so. Then we build this response, right? Successfully. I don't know. There's a double something. Okay, double S done. All right. So what we're simply doing here is, first of all, we're simply going to try to update this specific client, right? Because remember, when you want to update, you need to know the exact client that you want to update, right? So in this case, you can say find by name. Actually, we would have done find by ID, because for the most part, if you want to update a specific client, you're supposed to know the ID, right? So it's actually the ID is the good method to use, not the name, because client might share, the same name. So we can use the ID. So this is an optional again. So once we update, then we try to get the client by the specific ID that the client would have passed in our client DTO, right? Then if we find the new updated if we find the client object, we simply return whatever we have found for this select all from client where ID is equals to this. Then we simply return that. Otherwise, we can say update, or maybe you can say actually can say client not found, something, right? So which means if they try to update a client with an ID that doesn't exist, we'll simply say client not found. So it means their request was not successful. All right. So this is for the most part how you done the CRIDE API. Then the last one maybe will be the delete. So for the delete method, I might leave you guys to do the delete, but for the most part, it's almost similar to what we had. Okay, so actually, let's just quickly do it, right? So fun, then delete. So for the delete client, again, for delete, we need to know the client's ID that we want to delete. So in this case, we're going to pass the ID in our path parameter, right? And then this ID is going to be it's a long, right? And then it returns a response, a REST response. Then the type of requests, right, that we want to do, it's going to be a delete requests, right? And then for the path, so I'm simply going to copy what we had here, right? So for the path, it's going to be something like this, and then we simply delete the client that we want to use. So I'm simply going to copy. I don't want to write code anymore, so I'm simply going to copy this, right? And then we update it here. So first of all, we want to get the client that we want to delete, right? So once we get the client, then if the client is not equal to null, then we try to delete that client. So in this case, I'm simply going to say client details service dot delete client, and then we pass the ID. Then once we delete the client, we can say I don't know, client deleted or something, right? Then we build. Otherwise, if you don't get the client, you simply say client does not exist, like this, right? So there are so many ways of doing it. If you can do it in less number of lines, then that would be great. So I know this tutorial has been long already, so I think we'll stop here. So for the most part, this is how you create your REST layer. So again, Quarkus, it uses the JXRX as this specification REST endpoint for REST services actually. So in this case, the implementation that this JXRX uses is using REST Easy. So what we now simply want to do is to just quickly go ahead and run our application and test these endpoints, right? So to run our application, we simply say Grado, then Quarkus dev, like this. seem to be having an error in our client details service. So if we open our client details service, let's try to see what's wrong with our client unsatisfied dependency client repository. So the client repository, what's wrong with our client repository? So we declared it as an interface. So I think maybe we need to declare it as a class. So I'm simply going to save that change, and we're simply going to clear this out and restart. All right, so our application seems to have built. So in this case, just make sure that you declare your repository as a class, not as an interface, because we had an implementation here. So just make sure that it's a class, not an interface, right? So once you have done this, I think the last thing that maybe we might need to do in our applications.json file is try to connect our application to a database, because we haven't done any database connection here. But if we go and navigate to Google, to our browser, and we try to refresh this Swagger document, we should be able to see our new endpoints that we created, right? So for our client details resource, these are the endpoints that it has. So it has the get, the post, the put, and the update, right? So that's the beauty of using this small rel, the one that comes with Swagger documentation. So for the database configurations, what I'm simply going to do, I'm simply going to copy the configurations that I have, and I'm simply go ahead and paste them here. Right, so for the configurations, I had this configuration setup. So the database kind, the driver that we're using is Postgres SQL, then the username is Postgres, the password is this password, and then this is the URL to our database. So in this case, I'm going to be using a local database that I have in my local development cluster, which I'm going to run at port 5433, right? But if you are running your Postgres in your local, that is in your local machine, just make sure that you correct this port, because yours might be the default, the 5432, but mine, I'm going to run it on 5433 because I already have something running on 5433. So just make sure that you have this. Then we put the Hibernate generation drop and create. So if the table exists, then we're going to drop it, and then we're first going to drop it, and then we'll recreate it, right? So once you are done with your database connections, for the most part, I think you can actually go ahead and restart. Actually, we didn't need to restart. Restart your application, and you should be able to connect to this specific database. Right, so once you manage to run your application, just quickly go ahead and navigate to Postman. Let's go ahead. I think it was a basic salary. I don't know, something like this. So if I try to create, it's a post request, right? All right, so it has returned a 201, which means our user was created. So the edge was the one that was missing. So if I try to create another one, I'll say this is Mary Poppins. Then I can say Mary. Then in terms of the age, let's say she's 25. Right, let's try to create Mary. All right, so Mary is created and the ID is now equal to 2. So if I try to actually get all the users, right, so it was API/all, right, you should have 2 users, right? We have Daniel and Mary Poppins, right? So let's try to update. Let's try to update. Let's try to update. Was it updating by ID? So let me just quickly go back to IntelliJ, to our REST endpoint, right? I want to see what it was taking. So for updating, it was taking the whole object, right? It was taking the whole object, including the ID. right? So we want to update that other user. So if I go back to Postman, right, so in this case I want to update Daniel, which was the first user, this one. So I'm simply go ahead and update this one. So remember it takes the actual whole object, right? So I want to update the age, right? So the age here I'll put, let's say 45, right? And then maybe I update the surname to say maybe Ray, like so, right? So I've updated these two details. So let me just try to update this one. Okay, so if it's an update, it's a put request. So remember that. So if we say update, so there's an error. All right, I think I figured it out. So if we go back to our IntelliJ, so if we go back to our service, the client details service, if we go to our update query, I think the mistake that I had made is I had a comma here, right? So when it tries to run the query, it's not supposed to have a comma, because remember the query is update the table name, set name, blah blah, where, so here there was a comma here, so I'm suspecting that was the error. So if I remove the comma and I save, right, and I try to hot reload, and then I try to update to run the query again in Postman. So let's just quickly go ahead and try to run it, right? So if I say update like so, seems to be running now. Okay, so there was another error. So what was the error this time? So let's go back to IntelliJ. All right, so I actually had a couple of issues with the code that were written here. So for the most part, in our update query, I had objects like name. I think the name was also repeated here, so I deleted it, right? And also the other thing that you need to make sure that you do is to wrap your values with single quotes here, because if you don't wrap them with single quotes, Postgres will try to recognize them as column names, right? So you have issues. So once you have that sorted out, right? So, and also one last thing that maybe you may need to do, if you go back to application.properties, so I noticed that this one was annoying. I thought I was not going to encounter any errors. So just comment this line out, because what this does is whenever you restart your application, this will drop the tables. So which means if you are testing and if you already have data in your database, it will sort of like clear the data out. So you just need to comment out this so that it won't, or just delete it actually, because we don't need this anyway, because this one automatically drops the table. It's mainly used for maybe if you want to do unit testing or something when you don't want to persist your data. But for the most part, if you delete this, and I'm simply going to clear my terminal and I restart my Quarkus here. So while this is restarting, let's just go through the changes again. So make sure that you put single quotes on your values, especially for the string values. For the name, surname, the age, it's an integer, so leave it like that. Then the email, the basic salary was a double, so leave it like that. So where I did is an integer as well, so that when it runs the query, it will see the single quotes for the string values, right? That was the first change. And then the second change was here I repeated the name again to update it, so it was an issue. So just make sure that you have the correct values here. So once you have that, I think we might need to quickly capture it, because if I go back to my Postman, it won't have. All right, so once you have done creating your endpoints, you can actually go ahead and test the rest of the endpoints. I'm not going to exhaust all of them. If there are bugs, just let me know, but for the most part this should be working. So after this, I think the last thing that we need to do is to actually now try to build our application for the native image, right? So like I mentioned earlier during the beginning of the video, right? If you go to your readme.js, so right now what we're running right now currently, right, we're running it on JVM, right? So the JVM, like what I mentioned earlier on, this is the one that we're trying to avoid, right? So we want to natively build our images, right, or Docker images, right? So if you try to with this one, it was running on the JVM, so this won't be running natively, right? So if you want to like build it, so for example, you can say Gradle build, and then you can build your jar, and then you can run your jar, right? So this will be a fat jar that will be actually running, right? And as you can see, the application, it takes, I think, around how many seconds to boot up? So this one, it took 3.9 seconds, right, to boot up, right? So this one took around 3.9 seconds because this one is running on the normal JVM, right? So if you want to build natively, right? So remember, for building native images using Quarkus, it uses a different Java virtual machine from Oracle. It uses something called GraalVM, right? So GraalVM, it was mainly built for building applications, Java applications that they may run natively, right, to build native images, right? So for you to be able to create the native executable, so for example, if you have GraalVM installed in your laptop or in your machine, you can actually go ahead and quickly run this this command here, right? You can quickly build the application, and then you specify type as native, right? But in my case, if I say Java version in my terminal, I'm using the OpenJDK Java, right? So I'm not using GraalVM, right? So if I had installed GraalVM, I could quickly actually go ahead and run this, and it will build a native executable for me. But since I don't have Java running, I think I have Docker in my machine, right? So Docker is up and running. So if I say Docker, let's say PS, right? So I have Docker up and running, right? And there are no containers running at the moment. So if I run now this command, if you have Docker command, you can actually try to create a native executable as an image by running this command, right? So if I say grab a glue, then I run this command. So for the most part, this command will take a little bit of time because remember, we said it tries by all means to compile all classes at build time, make sure that it registers classes for reflection, registers actual classes for reflection that are not necessary, that we might not need general reflection. So it removes those classes, right? So, and also what it also tries to do in this case is to actually go ahead and run it as a native build. So this one, it actually has an error. So what is the error? So in my test cases, complaining about the test case, this one you cannot run it natively. So what I could do with this test case, I could just comment it. Actually, I don't need it for now. So now I can just comment the whole test case, and I rerun it. Right. So like I mentioned, this one takes a little bit of time because you have to compare all the classes and build, right? So I'm simply going to pause the video, and then I'll come back shortly. So once your build here is finished, to actually go ahead and spin up a container or a specific image for your build, if you go to the Docker native, from the Docker folder, you can actually see that this is the first command that we ran, right? So we build it to prepare it for native build, like preparing GraalVM and etc. Right? So this is a command that we ran, right? So to now actually build an image out of this Graal native image build, we need to run this command, right? So I'm simply going to clear my screen. So if I paste this, so if I say Docker build, so what we now want sort of like to build an image from this Docker file, right? So to build an image, we simply say we're running the Docker file, which is the native one, and then we are specifying sort of like tagging our image, right? We're calling it Quarkus rest, right? So if you run this command, right, right? It should be able to actually start the building of the native Docker file. So remember, when you run this command, just make sure that you comment the unit testing in the two folders, for both the native one and then the normal one, right? So once you're finished, so if you say Docker images, right? So if you run Docker images, right, from me, I have a couple of images. So if you run Docker images, you can actually see that I have an image that I ran that I created 14 seconds ago, which is called Quarkus REST API, right? So after you've done this, to now be able to sort of like spin up the container using the image that we created, we just copy this, right? So I'm simply going to run docker run image. Then we are running it at port 8080, right? So make sure if your instance of application was running, make sure that you stop it. Then we are now running the image that we just created, right? So if I run this command, right, it should be able to boot up our image, our native image, right? So from this, you can actually see that it is actually boot up our image, and then it didn't take time to boot up our image, right? But currently I think we are now having issues with the Postgres database, right? It's not recognizing the database that is outside of local cluster. So this one, I think this should be an easy fix. You should be able to fix this. So as you can see, for the native image, the application started in less than a second, right? So this was 0.088 seconds. So it started in less than a second. So this is the beauty of running your images, your native images using GraalVM and Quarkus, right? So you can actually see that the image started in 0.08. which is pretty fast, to be honest. So which means if you're building scalable applications, you won't actually need to worry about deploying changes, because it will spin in no time, just like that. So this was it, guys. So I hope you have learned a lot from this video. So I think we'll just end the tutorial session here. So what I will do is I will continue making videos on Quarkus, on tips, how to run your native images. So there are quite a number of things that we actually didn't touch, like for example, registering your classes for reflection. For the most part here, we didn't need to worry about reflection, because Quarkus automatically sort of like register these classes for you. So for example, we had a detail class like the model that we created, we didn't need to worry much about registering this class for reflection, because since it was on a REST endpoint, Quarkus automatically does that for you, so we didn't need to worry about that. But there are some cases where you actually need to manually register class for reflection, so that it will be included in the native build, right? So there are quite a number of tips that you need to consider when you are building your Quarkus natively, when you're building a native image, right? So just make sure that you are subscribed to the channel, because I'm going to be adding more videos on Quarkus, Quarkus reactive, Quarkus tips for native build, and so forth, right? So I hope you guys enjoyed this video. I know that it's been long, but I just wanted to walk you through, guys, through this interesting technology called Quarkus. I hope you guys enjoyed the video. Don't forget to share, to like, and to subscribe to the channel. See you in the next one.